Hello again, guys. For this topic, we'll have the first periodic trend that can be found in the periodic table, which is atomic radii of the uh, on the periodic table. So atomic radii, or we have first the atomic radius. So we have singular form. Okay, atomic radius. So this is the distance between the centers or the nuclei of two atoms in the molecule divided by 2. So we cannot have a single atom and then determine its radius. Why? Because in our discussion from the main energy levels, as well as on the wave functions and wave equations, if we try to locate the electrons, we cannot have the exact location of the electrons, therefore we have the region of space. So this region of space corresponds only to 99% of the time by which the electron can be found of. So this means that it can go beyond this boundary surface. So what the scientists or the researchers did was to have two atoms of the same type be placed side by side. For example, we have these two chlorine atoms, and then they measured the distance between the nucleus or the center of this atom with this nuclei or this nucleus, and then divide this by 2. So we have 198 picometers. So divided by 2, we have 99 picometers. So this is the atomic radius. And after performing this into a number of elements in the periodic table, they found out that there is a periodic trend, or there is a periodic transition in the atomic radius of the atoms. So again, we will just focus more on the representative elements or the group A elements. So we'll not discuss the transition elements in these periodic trends. Okay. So we have the hydrogen here, and then helium, and then we have lithium, sodium, potassium, and so on. Okay, so as we can see, the atomic radius increases down the group. So hydrogen is small, lithium is bigger, and then it goes bigger up to cesium. And then here, from left to right or across a period, the atomic radii decreases. So as we can see, from lithium to beryllium, it goes smaller up to neon. The same with this n is equal to 7, or the 7th period, we have the cesium going to Rn, or radon. Okay. So how is that explained? From top to bottom of a group in the periodic table, the atomic radius increases because the electrons occupy atomic orbitals that has larger value of n, or the principal quantum number. So just like in our discussion in the s orbitals, okay, so as we go down the group, we have a larger value of the first quantum number, or the main energy level occupied by the electrons. Therefore, it will attain a larger atom or larger space for the atom. For left to right, so the atomic radius decreases. So this is because of this explanation. The n value of the outermost atomic orbital stays the same. Okay. So for example, we'll go back to this slide. So here, okay, on this one, so the value of n is equal to 2, or the value of the main energy level is equal to 2. So the valence. Okay. In crossing a period from left to right, as each successive electron is added, so that means if the electrons are added, there is also a proton inside the nucleus that is being added. And this added proton increases the effective nuclear charge or the charge of the nucleus. So the result is there will be an increased attraction between the nucleus and the electrons. Therefore, in this one, so take note, in this lithium, we only have positive 3 as the charge of the nucleus. In this neon, the charge of the nucleus is positive 10 since we have 10 protons. So this means that in this positive 10, there is a large attraction between the nucleus with 10 protons and the electrons surrounding it. Okay, that is why it will attain a smaller radius or smaller region of space where we can find the electrons. Therefore, we have a smaller radius. So that is it for the atomic radius.